So our second speaker today is Dr. Ian Roach. Ian's role as activity leader for the Exploring for the Future Darling-Curnamona-Delamerian project saw the acquisition of new geophysical data and stratigraphic drilling across the Delamerian origin of New South Wales as part of the MINEX CRC. Today we will hear about the regional AEM program as part of that project. Thanks, Ian.
Thank you, Claire, and thank you to the survey for extending the invitation for me to come today. It's great to be able to talk about the new data sets that we've been generating. So, as Claire suggested, I'm going to talk about the AEM program in the Darling-Curnamona-Delamerian project. It's only one facet of the entirety of the project. Geoscience Australia acknowledges the traditional owners of and custodians of all of the country that we work on throughout Australia, and we acknowledge their continuing connection to the land, waters and community. We pay our respects to the people, the cultures and the elders past and present. I would also like to extend my acknowledgement to all of the many hundreds of landholders that we work with across Australia. The Exploring for the Future project is a $225 million project which is committed to, I can't read those notes down there, no, it's all gone. I'm just going to wing it, folks. It's a Commonwealth government. Oh, thank you for that, he's made them bigger. Lovely. So the EFTF project is, like I said, a $225 million project committed to supporting a strong economy, resilient society and sustainable environment. This is for the benefit of all Australians through an improved understanding of the nation's minerals, energy and groundwater resource potential. The program supports regional development and informed decision making across Australia, resulting in jobs and growth by gathering and analysing geological and geophysical data at a range of scales and making the results publicly available. The 2020 to 2024 EFTF is currently focused on 8 interrelated projects, which are listed here. And in selecting these areas, we chose areas which were cross-jurisdictional, so crossed many state and territory borders, where our work can make a difference for all of those jurisdictions. Don't worry, Tasmania is also included. It may not be listed there, however. The projects are undertaken in collaboration with Commonwealth, state and territory government and university partners, and leverage the capabilities of Australia's world-leading METS sector as well. And you'll see Darling-Curnamona-Delamerian is one of 3 deep dive projects around Australia. So the project is a regional scale study that aims to support economic development and in both resources and agriculture, and support the viability of mining, agricultural and pastoral communities. We chose the area because it's highly prospective. It is with the richly endowed Curnamona province, flanked by the underexplored Delamerian origin. There's potential for discovery of additional mineral resources to supply Australia's critical mineral needs. And the adjoining basins also contain potable groundwater, of course, that can support regional towns, agriculture and industry. So the DCD project was broken into 9 work modules, one of which concentrated on airborne electromagnetics, which is highlighted there. But you'll see the other work modules listed there, and results from those are coming out as we speak, one being the drill hole report, which dropped today, if you care to go and look for it on the Geoscience portal. And so the AEM project was flown across the entire study area, and it links 3 states as part of the Australia-wide AIAA initiative. One of those pictures Stefan just showed. I'd also like to acknowledge my colleagues at Geoscience Australia who are working in the HiQGA project. The AEM data acquisition is supported by the High Quality Geophysical Analysis, or HiQGA project, which works to improve understanding of commercial AEM systems through understanding their noise and uncertainty. HiQGA produces new inversion codes for AEM data and studies how uncertainty may be modelled to improve geological understanding. The GA has established the Menindee AEM calibration range to assess AEM systems. This allows us to methodically compare AEM systems and develop inversion codes to deal with many of the commercially available AEM systems flown by industry today, and compare the results against well-known geology. And you can see there's an example of two different systems, a helicopter-borne and an airborne fixed-wing system. They're inverted using two different kinds of inversions. All of the codes for the HiQGA inversions are available through GitHub, and of course we rely heavily on our collaboration partner, the National Computational Infrastructure, the high performance computer in Canberra at the ANU. So since 2017, Geoscience Australia has led the AIAA program, which has a goal of covering the entire continent at around 20-kilometre line spacing in partnership with state and territory geological surveys. Across the DCD project area, we have acquired additional AEM lines at either 2.5 or 5 kilometre line spacing in strategic areas in conjunction with the Geological Survey of New South Wales and MinEx CRC, who also complementing the South Australian NDI program. Here's just one of those 20-kilometre spaced lines, and this cuts through the Adelaide Hills and scoots out into the Murray Basin. And so you can see they're pretty easy to understand. Of course, the red bits are conductive sediments, of course, in the Murray Basin here. You can actually see some of the old beach ridges which are associated with those heavy mineral sands in strand lines. And of course, going up into the Neoproterozoic rocks of the Adelaide Hills here with some very strong conductors in there, which I'll talk about a bit more in a second. These conductors are things like the Tapley Hill Formation, which is a pyritic black shale in most parts, and is a very important metal host rock in the region, as you probably all well know. I'd also like to acknowledge all of the partners involved in the AIAA program, particularly the Geological Survey of South Australia. GA has a strong role in integrating geology and geophysics. As part of the AIAA program, we have interpreted the 20-kilometre spaced AEM lines across the Eastern Resources Corridor, as we call it, this corridor flanking South Australia, New South Wales, Queensland and the Northern Territory. It's about 300-kilometre wide corridor. The interpretations are of major chronostratigraphic surfaces, including the Proterozoic, Paleozoic, Mesozoic and the Cenozoic, as well as opportunistic geoelectrical stratigraphy within some of those. And the data are now available for free from the GA portal. And here's a little animation stepping through the interpretation layers. And so go get them at the GA portal. And I'd like to acknowledge Sebastian Wong, who led this part of the program. There are the addresses for downloading the data. The following are a few case studies taken from within the DCD AEM data set, which highlight the usefulness of the data for geological and resource potential mapping. Firstly, work by the HiQGA project has been used to improve inversions of AusAEM and other regional AEM datasets, including the Onshore Energy Security Program's FROME survey, which was flown in 2010. And this is a subset of that survey. And I've just been talking to people in the audience who are using that survey now. Woo, that's great. Shows the value of leaving good legacy data. High quality geological and borehole geophysical logging by the GSSA allows us to understand the geoelectrical stratigraphy of the Earth and interpret lithology, stratigraphy and groundwater features for each flight line. The example here shows how improvements in data inversion An earlier inversion, whoops-a-daisy, wrong button, an earlier inversion on the left here, a deterministic inversion which uses a single model to produce an inversion, compared to a probabilistic inversion here on the right-hand side, which uses over 100,000 models and combines them all to find the most likely result. Shows how changes in inversion technology can reveal more detail in the data sets. And here it's put against a recent NDI borehole that Tom might talk about a little bit later, from the Kwandong Vale region. Here, every single sounding from the aircraft is inverted every 15 metres. Here, every sounding every 500 metres is inverted, and just the amount of detail in this for a sounding every 500 metres compared to every single sounding is astonishing. And it really gives us a great insight into Murray Basin stratigraphy there, put up against the adjacent borehole right there. So it's breathtaking. The only issue being that this is incredibly computationally intensive and does require a supercomputer to do. We also use the AEM for cover thickness mapping. Of course, this image highlights shallow basement under the Murray Basin, say between Mannum and Blanchetown there. I've just indicated that Mannum sitting down here. Sorry, the topographic map underneath is very poor quality. This is all out of GoCAD, and it's very difficult to do flat raster images in GoCAD with very large data sets. But these are all of the 5 kilometre line space data between Mannum and Blanchetown, with the Murray River scooting down through here a ways, I think it is. The shallow cover hides Cambrian rocks of the Delamerian origin, including highly prospective rocks which were identified during the MinEx CRC NDI in South Australia. The AEM data provide useful information at depths of between 400 and 500 metres where the ground is resistive. Where the ground is conductive, of course, we see a lot less into the ground. Many of the copper systems in the Adelaide Rift Complex are associated with chemically reactive pyritic black shales, things like the Tapley Hill Formation, which are themselves excellent electrical conductors. There's still plenty of scope for mineral discovery in the outcropping Adelaide Rift Complex and in the Curnamona province, of course, but also under cover of the Murray and Eromanga basins, as shown by this oblique image of the AIAA DCD infill as well. So AIAA every 20 kilometres, DCD infill every 5 kilometres, and the Frome AEM survey partially in here. It's a fantastic thing. I'll just put on all of the mineral deposits, and you can see many of them actually line up with these conductive rocks. Many of them don't as well. So food for thought there about alteration. So there's your copper and gold occurrences out of Saurig. Wonderful Saurig. Thanks for fixing it too. It's great. So yes, there's still a lot of scope for mineral discovery. And I just thought I'd leave this here for a second so you can all admire the awesomeness of this data set. It is a truly astonishing data set, 300 kilometre long lines. Please take note of all the conductive rocks, which are mostly in the Adelaide Rift what is it? The Adelaide Rift, anyway. The Adelaide Rift Complex, and these may have huge potential for future mineral discovery. All of these conductors in here are all conductive rocks of one kind or another, either black shales or some conductive dolomites. And these are these chemically reactive rocks that people love to look for. In this case, we also apply the data set to community safety and our ESG. The AEM here we are using to map near tectonic activity. Here and it can actually show us previously undetected fault lines that don't have any surface expression. Here's an example of the Morgan Fault, which actually confines the Murray River on that north-south stretch in the Riverland, and the AEM is being used to update and assess earthquake risk throughout Australia, where AIAA is flown. The data are also used, of course, for aquifer mapping to model groundwater resources and also groundwater dependent ecosystems. There it is, Morgan Fault. It's got to be true. It's a line on a map. So, but you can see the offset in the conductive Murray Group sediments there. It really is quite spectacular, and it is one of the major bounding faults on the Murray River. Murray River is very heavily fault controlled. So in conclusion, we've got to end somewhere. Geoscience Australia continues to work with the state and the Northern Territory Geoscience agencies to complete the AIAA coverage. It's a spectacular data set already. It's only going to get better. We continue to integrate the AEM data with geology and geophysics to develop a range of interpretation products, and we continue to provide those data free to the public through the GA portal. So please go to the GA portal and get those data sets. Please download the latest drilling report from the New South Wales Delamerian Margins project as well. So thank you very much for your time.